Hi, I'm a student from Lisa Academy North and my name is Shandon Probst. I am in a group project with another student, Evelyn Huynh, and we have decided to choose the Graaff Generator as our PBL project. In our video, me and my partner will demonstrate and explain the science behind this project. The Graaff Generator, invented in 1929 by Robert J. Van de Graaff, is a machine that demonstrates the principles of static electricity. It is one of the most known machines and commonly seen in science museums, educating people about electrostatics. Electrostatics is a branch of physics that deals with the properties of stationary or slow-moving electric charges. Electrostatics' principle is based on one positive charge and one negative charge. When positive and negative charges are together, they are attracted to each other. Unlike the opposites, when you put two of the same charges together, they like to repel from each other. The Van de Graaff generator uses a motorized rubber insulating belt collecting electrostatic charge from a source and transferring it to a large isolated metal dome, on which a large charge accumulates. A pulley drives an insulating belt by a sharply pointed metal comb which has been given a positive charge by a power supply. Electrons are removed from the belt, leaving it positively charged. The band rubs across a piece of felt, which deals its electrons. The belt then spins around, and the electrons travel to the collective sphere on top of the Van de Graaff. The Van de Graaff uses electrostatic induction for it to work. This is called the N-122B Discharge Electrode. Here, a discharge is created from the electrons passing from the generator into the electrode, causing the spark that you see. It varies from distance due to the charges. This is the N-124 electric whirl. When it is placed next to the generator, it starts spinning. This is caused by the spokes being negatively charged by the dome, and the points are in turn ionizing the air, causing the electric whirl to rotate. This cylinder is called the N-132 Volta hailstone, and when placed near the generator, the particles bounce rapidly. This happens because they receive a charge which causes the pith balls to repel from the upper plate, in which they are attracted to. With aluminum foil pie plates, they levitate and fly off because it becomes positively charged. When two of the same charges are together, they like to repel from each other. They are basically trying to get away from the charged dome. For our ELA component of our project, we decided to make a newspaper detailed with articles about the generator. These articles range from explaining the science behind the generator to things like Van de Graaff himself. It is a very informational component of our project, and we suggest that you check it out. On the social studies component of this project, we look deep into the history of the Van de Graaff. The history includes topics like the first electrical experiments, Van de Graaff, and the machine he built. It is essential to check this part out if you would like to know more about the history of static electricity and the Van de Graaff generator. We appreciate you for watching this video and learning more about our project and PBL itself. Links to the ELA and social studies component are in the description box. Thank you for watching Lisa Academy North.